Alright, today we are going to do 10.3, which is polynomials and their factors. So what we're trying to do is we're trying to pull out whether it's another monomial or another polynomial or just some prime numbers. We're trying to pull stuff out of a polynomial. So let's just look at example 1 really quick, which is, so this is 10.3, I'll put that up here. 10.3, factor fx squared plus 10x. Alright, so what we want to do first is we want to see what these have in common. So you see that this is a 5 and a 10. You know that the greatest common divisor between these two is going to be 5, right? I can divide 5 by 5, and I can also divide 10 by 5. I can't divide 5 by 6, right? So 5 is the greatest common divisor, so I can actually pull that out of this problem. So we're doing the opposite of distribution. Distribution would be where we take this 5 and we plug it into each of these. So another thing that we have in common with these two is the variable. The variable is the same. This can be written as, I'll write it over here, 5x times x plus 2 times x. You can see that this and this term and this term are both multiplied by an x, right? So that means I can pull the x out. So I'm going to rewrite this as 5x times x plus 2. And there you go. That is our factored polynomial right there. Let's go ahead and look at, so this is example 1. Let's look at example 2 really quick. Example 2 is going to not be too much different than example 1, but we have a bigger polynomial. So we have factor x to the 4th plus, minus, that's a minus sign, 2x cubed plus 2x squared. So remember, this is a polynomial where the degree is 4, right? Our highest degree of one of our terms is 4, which means the leading coefficient would be this number here, which is a 1, right? We don't need to write the 1 because 1 times something is just the something. So I'm just going to write that over here. Degree equals 4, leading coefficient, I'm just going to do LC equals 1. This is just some review information, just to remind you guys a little about polynomials, which we talked about a while ago. But we are factoring this. So take a minute and look at example 2 and see what do all 3 of these terms have in common. Okay, so hopefully you had some time, or you took some time to think about it. We see that each of these terms, if we break it down, x squared times x squared using our exponential rules, minus 2x times x squared plus 2 times x squared, right? We see that all of these share an x squared, so I can pull the x squared out. So I'm left with x squared minus 2x plus 2. And so now let's look at each of these terms and see if there's anything common between these. So we can look at this and see that there's both of these two are multiplied by x, but this third one is not multiplied by x. Therefore, we cannot pull the x out. We also see that these two are multiplied by 2, but this third one here is not multiplied by 2, which means we cannot pull out a 2 either. So this is as far as we can go in terms of factoring, and we kind of have to leave that. And then example 3 is a quick example of a prime polynomial. So example 3 is 6x minus 24. And we're going to factor this into prime factors, which all that means is a polynomial that cannot be written as a product of polynomials. So we're going to pull this out, and it's not going to be a product of polynomials. It's going to be a polynomial times some whole number. So look at this. We see that both of these share a 6. Right? 6 times x minus 6 times 4. So I can pull a 6 out, x minus 4. And then we can factor this 6 into prime numbers, 2 and 3 times x minus 4. Sorry, I squeezed it in here, but that is what factoring into prime factors looks like, example 3. So this is our answer down here. All right, have fun.